research institution, private sector, partners, and growers. This session focuses on one of the most serious and rapidly expanding threat to the palm system globally, the red palm weevil. When it comes to a solution for this problem, a global integrated response led by ICARDA in close partnership with the government of UAE, national and international partners is here to present today. So please allow me to walk you very briefly through the agenda that we have for today, and then we will go ahead and move on. Like you see in the agenda, we will begin with opening remarks from our distinguished hosts. This will be followed by a keynote presentation that I will provide, introducing the Consortium for Red Palm Weevil Initiative, its vision, structure, and global significance. And then we will go to hear a presentation from different scientific work streams. And then after a short coffee break, we will conduct a panel discussion on integrated red palm weevil management, and also the closing remark at the end. So right now, without further ado, I want to, it's my pleasure now to invite Fatima from the International Affairs Office, UAE Presidential Court, to kindly deliver the opening remark. Fatima.
Good morning, everybody. Thank you for being with us today. For those of you who don't know me, my name is Fatma Nulla. I work at the International Affairs Office of the UAE Presidential Court under the leadership of Her Excellency Mariam Al-Nuhairi. I'm going to give you a speech, but before I do that, I just want to touch on a little bit of what Dr. Mujib is saying about the work that we're doing for the red palm weevil. I think this is something that we in the region have been working on for many, many years. It's been a challenge. And really the goal of bringing the international community and the local stakeholders is to try and build on the science, to build on the innovation, to harness the knowledge from the CGIAR and ICARDA and bring this into the UAE. So without further ado, it is my great privilege to welcome you to Abu Dhabi for those of you who are visiting us, and we've really been looking forward to people returning to the country. So welcome. And we're all gathered here for a common cause. This very difficult yet very, very beautiful red bug. In the UAE, the date palm is part of our identity. It's woven into our history, our hospitality, our vision, and the vision of the late His Highness Sheikh Zayed Al-Nahyan, may his soul rest in peace. His legacy was rooted in stewardship of the land, of water, of agriculture, and these are values that still continue to drive us today. And protecting the date palm is therefore not only a national responsibility, but also it's a shared cause of community. And in more than 50 countries, we see that date palms sustain the livelihoods of heritage and security. The red palm weevil has challenged the scientific community for decades, and many of you who've been working in the industry probably know this better than I do. And the case for acting together has never been more clear. This is why the UAE and the Gates Foundation have come together to develop the Consortium for Red Palm Weevil. Under ICARDA's leadership, the consortium brings together our national partners, such as the Ministry of Climate Change and Environment, the Abu Dhabi Agriculture and Food Safety Authority, who have been great partners, and the Khalifa International Award for Date Palm and Agriculture Innovation, and as well as ICBA. And we've been working together alongside some of the world's most leading research institutions. And 6 months ago, this was a commitment. I would say more than 6 months ago. This was one of the main things that we did was join the CGI-AR. And through this commitment today, this program has now been delivered and is running across the UAE, Egypt, Morocco, and the consortium has built a foundation that's required in order for us to now start this work. So we have laboratories established, we have partnerships formalized, and 40 pilot farms identified across the UAE. 28 are already under assessment, and in February we've entered the next phase, moving from the preparation to the work in the field. And this is the kind of work that the UAE's partnership with the Gates Foundation has built to deliver, convening the best science, the right partners, and the resolve to see it through. The date palm has sustained this region for generations, and what this consortium does and what you do will ensure that this kind of work can continue. So to bring this work to life, I'd like to leave you with this short film before we get started. Thank you.
البروجرام لو تكلمنا عن سوس النخيل الحمراء هي آفة تعتبر من أخطر الآفات ومن أكبر المشاكل اللي تواجه مزارعين النخيل بالذات، لأنها تضرب بالعمق ما تحس فيها، أنت ما تشوفها إلا بعد إيش يكون عندها تدمير داخل في وسط النخيل.
The Consortium for Red Palm Weevil Control was formed by the UAE and the Gates Foundation to tackle a beautiful yet deadly pest, the red palm weevil. This project is done in partnership with ICARDA and our national partners, including the Ministry of Climate Change and Environment, the Abu Dhabi Agriculture and Food Safety Authority, and the Khalifa International Awards for Date Palm and Agricultural Innovation, and brings in some of the world's leading research institutions. Together, we are mobilizing the international community right here in the UAE, directing some of the best science and innovation toward tackling one of the biggest pest challenges in the UAE and the region.
The innovations we've seen emerge from our partnership led by the UAE's presidential office hold immense potential to drive sustainable food production, particularly for smallholder farmers. The Consortium for Red Palm Weevil Control is a huge part of this effort, and I want to recognise the important progress achieved thanks to the UAE's efforts.
The red palm weevil is so devastating because it attacks silently from inside the tree. By the time you see the damage, it's often already too late. That's why early detection and integrated solutions are so important.
The program is built around 5 work areas, each led by a partner, but designed to function as one approach. ECPE begins with safe, nature-based solution using biological control and smart craft chemicals and build long-term resilience. Meanwhile, IITA is developing precise innovative methods that disrupt the best reproduction and development. In parallel, ICRISAT is using AI, remote sensing, and machine learning for early detection, early warning, and early action. ICBA drives key good agricultural practices, including irrigation, soil health sanitation, and certified seeds.
That is the model we have built, and the UAE's role is to make sure that this knowledge reaches the farms, the farmers, and the communities across this region who need it most. That is what this consortium makes possible.
الحقيقة بدعم جهات الاختصاص وجهودكم أنا سعيد فيه وكل الشكر لكم.
So thank you very much, Fatima, for your
is a pleasure to welcome you to this side event held alongside the 8th International Date Palm Conference. This session is not about presenting a finished solution. It is about collective learning, alignment, and strengthening of a platform that is still evolving. One designed to address a challenge that continues to test all of us. Red Palm Weevil reminds us that the agricultural threats today do not respect borders, mandates, or disciplines. They require responses that are integrated, anticipatory, and sustained. The Consortium for Red Palm Weevil Control was created precisely to respond to this reality. It brings together researchers, innovation, regulation, and field practice within a single but a coordinated framework. Today's agenda reflects the intent that you will hear about: advances in early detection technologies, the role of digital tools in risk anticipation, biotechnology innovations under responsible development, and the importance of good agricultural practices as the backbone of the prevention. But equally important are the conversations that will take place beyond the presentations around data sharing, regulatory alignment, capacity development, and scaling pathways. This event is an opportunity to test assumptions, identify gaps, and strengthen partnerships. It is also an opportunity to ensure that the Consortium for Red Palm Weevil Control remains responsive to country needs and to continuously learn from each other as we advance this scientifically robust and implementation-focused endeavor. As we move forward, your feedback and engagement will be directly shape the next phases of this consortium. I encourage open dialogue, constructive challenges, and a focus on how we move from promising innovations to sustained national and regional impact. Thank you. I finished my formal part of the speech. Now allow me to add a few words. Of my own. I think it's important, first of all, to recognize the leadership of the UAE through the Presidential Court, the International Affairs Office, together with the Gates Foundation, who actually enabled, maybe for the first time, the scale of response that we're seeing today. But the success that we are seeing today is an important milestone of a process that started many years ago. Since we've been coming here, meeting around the Dead Palm Weevil, on the margins of the Khalifa Award, Dr. Abou Zaid has been quite instrumental in bringing the ministerial group from the GCC and the entire Arab world and beyond, together with the technical partners from ADAFSA, from IGBA, from many of the local and regional institutions, even within the GCC countries, to underscore how important is that we come together to address this challenge. No single country, no single institution, no matter how much capabilities or funding or knowledge you have, will be able to resolve it alone. So I think the key word here is the collective action. And once you're able to control the weevil in one location, you should make sure that it doesn't go around or come back again from one place to another. So the series of Abu Dhabi declarations, I think yesterday there was the third commitment from the ministerial group. Yesterday, during the main event of the Khalifa Award launch, I think we've heard it loud and clear from ministers, their confirmation and commitment to continue to work together. And I think, if you look around in this room and also on the screen, you will see many scientists that come from across the world, putting their knowledge, their experience, their capabilities together. And I think that has been the central piece, Fatma, as we were trying to conceive this right from the very beginning, it was recognized, ICARDA is providing a leading role, but does not have all the capabilities, does not have all the answers, does not have all the solutions. But it's important now that we bring that ecosystem of knowledge and capabilities from across the globe to be able to achieve this very important task of controlling the weevil here in the UAE, but also within the GCC, and then spread to many other parts in North Africa and also in the southern part of the hemisphere. And we have seen the excellent mapping of the impact of the weevil across the globe that was.
Thank you so much for setting the stage, ICARDA DG Ali Abu Sabah, and also the global context for this initiative. It is now my honor to invite His Excellency Professor Dr. Abdul Wahab Zaid, Secretary General for the Khalifa National Award of the Date Palm and Agriculture Innovation to provide an opening remarks for you all.
Bismillahirrahmanirrahim. Distinguished guests, excellencies, ladies and gentlemen, it is my pleasure to welcome you all to this important gathering of the Combating Red Palm Weevil Consortium, held in conjunction with the 8th International Date Palm Conference here in Abu Dhabi. The red palm weevil continues to represent one of the most serious threats to date palm cultivation worldwide. Its impact extends beyond agriculture, affecting food security, rural livelihood, and the sustainability of this vital sector, particularly across the Middle East, North Africa, and beyond. Before I talk about today's gathering, I would like to just share with you how important this subject is to the United Arab Emirates. For the last 10 years, Khalifa International War took as part of its commitment to prepare the fertile land for an international project which was achieved. I remind you that in 2019, we had the first ministerial meeting here in Abu Dhabi, which concluded what was called Abu Dhabi Declaration Red Palm Weevil #1. In light of that meeting, $5 million was raised, and it was provided to RNE, Food and Agriculture Organization of the United Nations, and after 5 years, in 2024, Khalifa Award organized the second international gathering for the red palm weevil, and FAO was invited to provide, all of us with the funding. So then was the Abu Dhabi Declaration #2. Now, 2 years later, we have the Abu Dhabi Declaration Red Palm Weevil 3, which concluded its work yesterday with the presence of various ministers, honorable ministers in the Arab world. All this was prepared within the scope and in full collaboration with the International Affairs Office. So I would like that the history is important so we can see all together where to go from now. Today's meeting reflects our shared commitment to strengthening international cooperation, advancing science, research, and promoting innovative and sustainable solutions to combat these destructive pests. The C4RPWC Consortium for Red Palm Weevil Control Program platform, we have witnessed the power of collaboration. This is very important. Bringing together governments, research institutions, and international organizations under a unified vision. We are particularly encouraged by the process made so far, including enhanced knowledge exchange, coordinated research efforts, and the development of integrated pest management strategies. However, much remains to be done. This meeting provides us with a valuable opportunity to build one of the momentum generated by our previous engagements, align our strategy, progress, and priorities, and further strengthen partnership that will enable us to move from research into impactful implementation on the ground. On behalf of the organizers, I would like to express our sincere appreciation to all partners and participants for your continued dedication and contribution to this important initiative. As you know from this international program today, the full day was programmed just for the red palm weevil. Now there is room A, B, and C are also presenting research and results of the red palm weevil studies all around the world. So I am very pleased, and we look forward to productive discussions and positive outcomes. Thank you for your time.
Thank you so much, Your Excellency, for emphasizing the importance of innovation, partnership, and also providing the history of what has happened so far in the UAE and also in the region. So with that, I will go ahead and transition to some few slides regarding the project itself, and then after that we will go to each work stream and provide you with much more detail. So first of all, when it comes to the challenge, the global challenge that we have in front of us, so the Consortium for Red Palm Weevil Control is a flagship research for development platform led by ICARDA under the CGIAR system. It brings together government, CGIAR Center, National Agriculture Research System, advanced research institutes, the private sector, and grower to address one of the most damaging cross-boundary pests affecting the palm system worldwide. The diversity of partners reflects the complexity of red palm weevil challenge that we have in front of us. So the red palm weevil is one of the most destructive, invasive pests affecting palm system worldwide. It's spread across Asia, the Middle East, Africa, the Mediterranean, also has turned into a global biosecurity concern at the moment. Beyond production losses, red palm weevil threatens agricultural trade, quarantine system, rural livelihood, and cultural heritage. So late detection, a as you heard before also in the video, often means irreversible damage. So this makes prevention and early detection not just preferable, but essential. So why Consortium for Red Palm Weevil? Consortium for Red Palm Weevil has created because red palm weevil cannot be solved through isolated intervention or short responses. Red palm weevil is cross-boundary in the system, in a systematic problem to everyone. Addressing it requires coordinated action. Coordinated action across science, digital intelligence, and farm practices. And also along with that, policy system. When it comes to the consortium model, Consortium for Red Palm Weevil represents a new, innovative, global consortium model. It is led by CGIAR, globally connected, and designed as a long-term platform rather than a short-term project. It is a single project. It is not treated in a way like a single project, but rather a technology pipeline, and also a global platform that aligns research excellence and national priorities in field realities. This structure is essential for addressing the pest itself that threatens globally food system and trade. This allows us to link advanced science in real worldwide implementation. The vision and strategic approach to the program is very clear. The consortium vision is to build around one simple word. It is early detection, early warning, and early action. This shifts red palm weevil control from reaction to anticipation. It is supported by digital innovation, bio-based and biotechnical solutions, and good agriculture practices, and strong participatory systems that we have built in. The overall program governance and architecture is very strong. Consortium for Red Palm Weevil control operates through 5 interlinked work streams that we will hear about later in separate presentations, each addressing a critical component of the red palm weevil management. Scientific coherence and rigor are provided by independent technical steering committee that we have around the program. This structure ensures credibility, integration, and accountability at the same time. Normally, when we talk about Consortium for Red Palm Weevil, we are talking about an integrated solution bundle. When it comes to integrated solution bundle, what it is? A key innovation of the Consortium for Red Palm Weevil is the concept of the integrated solution bundle. We do not deploy individual technologies in isolation. Instead, we bundle technologies, data tools, management practices, and policy support into a deployable and scalable package. The workstream contributions that we have, workstream 1 and 4 that we have for the program, generates scientific and technical innovation. Workstream 5 integrates, validates, and prepares these contributions for deployment, adapting and also scaling it more to other low and medium income countries. This ensures that solutions work under field conditions in different areas. The overall program, UAE, as you heard also before from our colleagues, the UAE plays a central leadership role in the innovation and also as a validation innovation hub. Solutions are tested here before being adopted and scaled to other countries, including low and medium income countries. Since the UAE, and right now we also have added Egypt, are selected as shown in the GIS map here, or more for the primary engagement and testing the bundle that I just talked about, and then moving it on. The progress of the program will be explained a little bit detailed by my colleagues describing each work stream. But phase one of the program focused on building strong foundation. This includes red palm weevil risk modeling, digital dashboard, sensor evaluation in field readiness in the UAE and also in Egypt. This ensures scientific rigor system alignment and credibility, laying the groundwork for durable impact in phase two and beyond. Early value that we talk about in impact, early evidence shows that prevention-focused systems significantly reduce losses and long-term costs. You will hear about this in much more detail in workstream level presentation. This integrates model, also reduces reliance on chemical control that we are all so fed up about. So right now, what happened next? The slide that we have here summarizes how strong foundation we have already established translate into clear field-level objectives moving forward. This integrated approach spanning science, digital innovation, and system-level adaptation is exactly what our upcoming panel will explore. They will talk about how integrated red palm weevil management can move from pilot to policies and then lasting impact. We have also shown the system that we talk about. Now let's talk about each practice separately. This last slide brings us very naturally to each of our presentations that will be provided by my colleagues. So here I want to end my presentation and then start to asking each of my colleagues to come and present part of their presentation for you. Yeah, thank you so much. So we begin right now with the work stream one, bio-based solution, focusing on ecological and nature-based innovation as the backbone of sustainable red palm weevil management. So it is my pleasure to invite Dr. Samira Mohammed Faris from Ethiopia, Kenya, to present the progress in key innovation under work stream one. Dr. Samira.
Assalamu alaikum. Okay, as we've introduced the work stream one, development of nature. Yeah. Okay, as Dr. Malik said, this work stream is focused on development of nature-based climate resilience solution for the management of RPW. And just for the benefit of those who are not familiar with the work stream, it encompasses 4 objectives. One of them is to adapt and develop new existing trapping systems. Of course, we are not saying they are not there, they are not there, they are there, but we just want to explore if we can develop more efficient new ones by also exploring for some chemical from host and non-host parts. Another one to adapt and explore for new entomobacillian and endophytic fungi. For those insects, the way we get sick, the insect gets sick. And we also want to explore those entomobacillian fungi that can cause high mortality for these invasive and devastating pests. And also we want to look for efficient natural. Initially we are looking for coil growth. But now, here we are exploring a different approach, which I'm going to talk about it in the subsequent slides. And at the end, we are using modeling approach to guide this our intervention. The modeling approach will tell us this particular area is suitable for releasing this particular wasp, but that one is not. This is good for implementing the endobacillian, that one is not. And It has already mentioned by ICARDA director, Baumudi. Those goals are very important. Enable literacy is very important. Indigenous knowledge that we also need to consider. And of course, partnership is very important. As we say in Arabic, you cannot collaborate. So partnership is crucial. Okay, we started this. We don't want to reinvent the wheel. We want to know what is existing. And we did a very extensive desk work to establish what kind of technologies are existing, where are they, how efficient they are, whether they are available or not. And this work we came with, most of the research so far is done in Asia and in Africa and to a lesser extent in Europe. And this is, I mean, in the Americas. And this is much understandable because the basis is not. And when it comes to the technology, things related to, of course, chemical insecticide. That is widely used, both, of course, preventive and curative. And the good things, there are also some research done on biological control, whether they are using into pathogenic fungi or virus, but of course to much lesser extent. And the good thing, some of those one are many of them commercial available, especially when it comes to chemical control. This review is very much advanced stage, and very soon we publish a paper on the same. Next, as for now, we don't have the best. Soon, the students are going to be based in UAE and Egypt, but for now, we start looking at volatiles from host and non-host plants, and there's some commonality across those plants, and we want to see whether they have any attractiveness or repellence for the RPW. Next. When it comes to the pathogenic fungi, we start subculturing of what we have in our repository, and there are some which have been tested for. We have tested for other weevil, banana weevil, and they are quite effective, and we are hoping they could also be effective against RPW, but this is yet to be tested. We also have heat-tolerant isolates. They are originated either from Sudan, Senegal, or northern Kenya, and we want to test them. This both Metallidium and Bivonium. When it comes to the infected fungi, we also have like something like Trichoderma. We already test some seedling, and we also growing other from the seed. We want to inoculate them to see whether they can induce resistance in the dates. Next. And okay. To start. To establish the extent of the RPW is transformable. It doesn't require passport, can travel anywhere. So we want to establish where it has done. One of our deliverables is to establish the incidence and the spread in East and Horn of Africa. So we embark on intensive survey, starting with Kenya. In Kenya, we did a survey along the coast of Kenya, right from all the way close to the Somali border, but we could not reach there because of security issue. But we didn't find RPW, good news, but also we did not find even the African palm, but the one which we find is the horn beetle. It's a very devastating pest also on the coconut. Then we extended our survey to Uganda. There the red palm, the African palm will be very rampant, but people are using it for other causes. They are looking at it as more ni'ma than now. They use it as food. So, and there, from what we collected, we could find different morphotypes. And we are suspicious. Some of them look like RPW. We have taken them for molecular analysis. We will establish whether they could be red palm or just a morphotype of African palm. And we established, currently, we already established which can produce from it glyphosate, and we use it for various bioacids, whether for encapsulating the tuberosity or for encapsulating of double-stranded RNA. Next. Here is about the biocontrol. As I mentioned initially, we are thinking of classical biocontrol, which is this approach which is undertaken for any invasive pest. They come in the invaded region without the natural healing. So the natural thing is to go and look where they come from. So far, there is no record of where any efficient parasitoid in the Southeast Asia. The good thing, there is very efficient parasitoid in Brazil. Of a related pest, that's Balmal. And this could be explored for management of RPW. The problem is the reading. They are unable to establish a good colony. The good thing, we have a very good knowledge on reading. So we will just adapt our knowledge on reading this another technique to read this parasitoid and import it in UAE and Egypt. If I'm right, I was told this parasitoid was invented some time back in UAE, but they are unable to have it here, and here we have the technical expertise to read these parasitoids. Next. Now, we want to establish how far this pest has spread in East Africa using modeling approach and what the potential of having spread further. We use two modeling approach. One of them is the ecological modeling, which uses just the incidence of presence and absence. But this has weakness because it does not take into consideration the life cycle of the pest. So we will supplement it with another modeling approach and become more robust. So as you can see, in future climatic scenarios, the pest has likely to start to expand even in social beyond. But more than that, we need to be very cautious. Now we are taking for example. But there are other ways. The down map is for red bound meagle, which is also it can invade and can establish in the Middle East, North Africa, and even South America. Next. Of course, all the interventions we are making, we need them to make them more sustainable. And you can only make sustainable by building the capacities. So currently we are building at different level. We have two postdocs currently, and already we recruited two master PhD students. And the good thing, we have them from all corners of the application. We have, and we are trying also to be gender sensitive. Already we have one PhD student, female from Lebanon, and a gentleman from Sudan, he is based in Saudi Arabia, already working on RPW, and we are hoping to get another female student working on biodiversity side, and we have a master student working on resistance with Dr. Hamadu from Kenya. With that, I want to say thank you, and thank you for listening.
Thank you very much, Dr. Samira. Thank you for highlighting how bio-based approaches contribute to the prevention, suppression, and also a long-term sustainability. So we move to workstream 2 now, workstream 2, biotechnological solutions, which explore precision next-generation tool to strengthen plant resistance, introduce reliance on chemical control. I kindly invite Dr. Lena to present the progress and also the vision for this work stream. Dr. Lena was not able to come in person, so she will be participating with us virtually in providing the presentation. Dr. Lena, the floor is yours. We apologize for some technical difficulties that we are facing.
Good morning, everyone. Dr. Mazib, can you confirm if you can hear me?
Yes, we can.
Hello, can you hear me?
Yes, we can.
Good morning, everyone. Dr. Mazib,
We can hear you.
Okay, so I'm going to present on the work stream 2, which is biotechnological innovations for control of red palm beetle. Maybe next slide, please. Yeah, so the main objective of this work stream 2 is to develop and implement the sustainable biotechnological driven solutions for controlling the red palm beetle, which is a devastating the global date palm cultivation. So basically it has 3 components. The first is the genome editing, and we are using the CRISPR-Cas based genome editing for both for insect as well as for the plant. So in the insect, actually we are in the weevils, we are actually targeting more like essential genes which are involved in the reproduction, so that the insect can become sterile. And then for the plants, we are targeting some of the genes which can provide the resistance, the host plant resistance into the plant for the controlling the red palm beetle. So basically it develops the resistance and it minimizes the infestation. The second technology is the RNA interference, which is also known as RNAi, and apply the double-stranded RNA, and so we can deliver the double-stranded RNA as like a biopesticide for the control of the red palm beetle. And this is like a solution which we feel is very safe, because it will reduce the use of the pesticide, and also it can be developed shortly and can be scaled up between the period of the phase 1 of the project. The third technology is the microbiome-based intervention, which explore the microbiome for like naturally suppressing the red palm beetle population and the damage because of it. Next slide, please. So if I go a little bit more detail on how the genome editing can or the double-stranded RNA based biopesticide can be harnessed for controlling of the red palm beetle. So we are applying actually genome editing to knock out as I mentioned, the fertility genes in the male, and then which is like very targeted and precise and specific, so that it will not affect anything else, and then the insects will become sterile. So that means you can reduce the population using that, and you're using the CRISPR-Cas9 based genome editing. The second technology for the insect, as I mentioned, is like double-stranded RNA technology to silence the essential genes which are required for reproduction, but also the survival of the red palm beetle. So both these technologies support the integrated pest management practice to reduce the pesticide residues and the resistance development. The key consideration here include the identifying the requirement for the scalable double-stranded RNA production, which I think we will manage, because we have like already planned, we already started working on it, and the cost-effective formulations, so that farmers or the growers will be able to afford that. But then the major thing we are working on is like a delivery system, how these RNA-based biopesticide will be delivered to the big farms of the date palm. And definitely we will take the regulatory clearance before these technologies can be deployed at the large scale. Next slide, please. And now we are working, so the previous slide was more working on the weevil. Now I will talk about more what we are doing on the date palm, because we are trying to develop the date palm using the genome editing, the resistance for the red palm beetle. Here we are using the CRISPR-Cas9 technology for editing, and precisely we will knock out the susceptibility genes. So these are the genes which are essential for a weevil to infect the plant. So if we will make these genes non-functional, means weevil will not be able to infest the date palm. So here we are using genome editing, which can strengthen the defense pathway in the date palm, modifying the endogenous susceptibility genes without introducing any foreign gene. So we will make like a very precise small changes in the endogenous gene and not introduce anything new. The another technology in the plants itself we are also using is the RNA interference, because the delivery through the sprays or something sometimes is quite labor intensive, but also maybe sometimes the double-stranded RNA are not stable. So there is another approach is also you can express the double-stranded RNA within the plant itself. So we are developing that technology in the plant by expressing the insect-derived double-stranded RNA, resulting in the mortality of the red palm weevil. So both genome editing and the RNAi technology reduce the vulnerability of the date palm to the red palm weevil infestation, and also decrease the dependence on the synthetic insecticides. And we will also, in this consortium, we're also trying to see if we can create the enabling environment, like a regulatory environment in which the genome edited and then which will be like a non-GM, as there will be no foreign gene integrated. It can be there will be policies developed so that they are treated similar to the conventional varieties. There are actually in several countries there is already this type of policies in place, but we will also see where if there is no foreign gene integration, then genome edited products are treated as the conventional. Within Africa there are Kenya, Nigeria, Ethiopia, Malawi, Ghana. These are the countries where there are already these type of policies in place, and we will make sure that we can sensitize the regulators and work with the regulators together, so that in our beneficiary target countries these type of technologies can be utilized and which are more environmental friendly. Last week we did this a workshop. Not last week, actually early this week. It was started on Sunday in Egypt, and where we actually gave this presentation on the genome editing to the regulators and the high-level policy makers, so that they can understand the technologies, but then also consider creating the enabling environment for this technology. Next slide, please. So the third approach in this work stream 2 is the microbiome-based technologies to control the red palm weevil. So this utilizes the beneficiary organisms which are present either in the gut of the date palm, but also the gut of the red palm weevil, but also surrounding in the soil in the date palm. And so we will be using this beneficial microorganism to disrupt the pest survival and the behavior. So this is more like targeting the gut symbiont as an emerging biological control strategy with low ecological disruption, because it will not create any changes into the environment. Will also disrupt the essential microbiome pest partnership, which will impair the red palm weevil survival and the growth by affecting mating and reproduction. So key consideration here includes integrating the microbiome intervention with enhanced monitoring tools, and also enabling the regulatory framework. And this will contribute to scalable, environmentally friendly, responsible red palm weevil control, and which will benefit the growers and smallholder growers as well as the commercial growers. Next slide, please. So far we have made quite good progress on the work stream, and so we have already identified the target genes and preparing the delivery system, how these genes for the knockout can be delivered into the insects and as well as in the date palm, and we are optimizing for both for the double-stranded RNA as well as CRISPR, and then so on the main issues are with there are not that much work has been done on the insect for delivering the CRISPR reagents. So good progress has been made in New York University at Abu Dhabi. That's the group who are working on the insects. And then similarly in the date palm genome editing and RNAi, this is the work which we are doing it at IITA. We already have a regulatory approval, and then also we have imported the date palm germplasm from Egypt. So now we have some germplasm already multiplied, and we are now optimizing tissue culture transformation, but also we have identified the targets for the essential genes knockout and preparing the construct. So the good progress going on. Here what we are also doing is, because date palm actually feeds the sugarcane, and sugarcane has a short cycle. So we are for the proof of concept, we are testing the technology in the sugarcane, so that when we go, we know the technology is already working, as date palm takes long time for the regeneration. And on the microbiome-based strategies, their samples have been collected from different field sites in Egypt. The protocol has been optimized for the sample collection, DNA isolation, and also the library preparation for the next generation sequencing. So the samples will be sent for the sequencing soon. Next slide, please. So the biotechnological tools actually present the pathways for accelerating farmer adoption and long-term sustainability. Here we are trying to build actually the host plant resistance. So that means once the resistant varieties of date palm are available, then growers doesn't have to do anything. They have to just plant those things. So genome editing provides a permanent, like a stable, I will say, non-chemical barrier against the red palm weevil, and ensuring the robust chemical-free protection for the agriculture product. And it is very actually precise technology, so it will not affect anything into the plant. It is only precisely affecting these susceptibility genes. And also using the RNAi and the microbiome strategies allow for the targeted pest elimination with zero collateral damage to the surrounding environment, because it's environmental friendly and it will not affect any biodiversity. So there will be also the economic resilience, because it will develop the safeguards, multi-million dollar palm industry investment, while simultaneously reducing the environmental contamination risk because of the using the pesticides. And it's a holistic integrated pest management. So integrating these advanced tools create a robust, a multi-layer defense system, because we are controlling both the weevils and also developing the resistance in the plant. So it will provide double layer resistance that will remain far more resilient and effective than currently industry standards. Next slide, please. So in the end, I would like to thanks for the team working on it. So there is a team from New York University, Abu Dhabi. There is the ICARDA team based in Egypt, and the IIT team based in Nairobi. So the three teams, we are working very closely for developing this biotechnological solution. So I thanks all the acknowledge here all the also all the partners and the funding support. So thank you very much for listening to me. Thank you.
Thank you so much, Dr. Lina, for outlining the biotechnology and also how biotechnology can complement and the components of the integrated bundle in a responsible and scalable way. Part of our presentation and work stream, because of the travel issues that some of our colleagues faced, Dr. Lina was able to participate virtually, and our next group presentation is for work stream 3. Our partners are in India and California, so we asked them to record their presentation and send it to us. So right now, our next presentation is for work stream 3. And work stream 3 is about digital innovation, smart detection, which underpin early detection, early warning, and early action framework for the Consortium for Permeable. And this is presented by our partner Ecosat in close cooperation with ECARDA and Spectral Analytics, our sub-partner, and also UC Davis.
Greeting and welcome. We are pleased to present Workstream 3 of our project on red palm weevil control. This workstream is all about digital innovations and big data analytics. This video presentation is prepared in collaboration with our partners, the International Crops Research Institute for the Semi-Arid Tropics, International Center for Agricultural Research in the Dry Areas, Spectral Analytics, and UC Davis.
Let's start with setting up the context for the Workstream 3. The chart on the left shows the palm weevil impact timeline across 6 progressive stages, from initial infestation and early larval feeding in the first weeks, through visible symptom onset and advanced damage, to severe decline and terminal phase beyond week 12. Critically, by the time visible symptoms appear, the tree is often beyond recovery. Several studies reported use of satellite remote sensing technology for detecting RPW damages, but it typically detects damage only from the advanced phase onward. It has been also reported that multispectral, thermal imaging, or hyperspectral drone imagery can pick up crown yellowing that may occur during weeks 3 to 4 after infestation, and acoustic sensors can detect larval feeding as early as weeks 2 to 3.
This brings us to our central challenge. How early can we detect infestation? That question frames our 5 guiding research questions, leveraging the existing knowledge to understand what has worked. How effective are bioacoustic sensors in early detection? What combination of methodologies are necessary for using high-resolution satellite imagery? Identifying the best AI/ML models, and empowering stakeholders through digital decision support. Now, based on this context, the overall objective set for the Workstream 3 is to develop a robust early detection, early warning, and early action system for RPW management, leveraging cutting-edge digital innovations. This objective is delivered through 5 interlinked outputs. Output 3.1 is about an AI-powered chatbot built on a comprehensive literature corpus. Output 3.2, where we will be testing efficacy of acoustic sensors for detecting RPW. Output 3.3 is about multi-scale imaging data analysis. Output 3.4, where we will be developing the digital platform for early detection, early warning, and early action. And output 3.5 is about multimodal data integration and predictive modeling. Now we will take you through some of these outputs and activities. First, let's start with the data requirements and data sourcing methods. Starting with in situ IoT sensing, a core component of output 3.2. After an extensive market survey, we shortlisted and procured 4 commercially mature bioacoustic sensors: Agrant, Palmaire, Permia Sensing, and PalmNex. Each of these sensors detects larval feeding activity inside the palm trunk, but they differ in design. Our objective is to rigorously compare their efficacy under identical field conditions. The testing follows a 2-phase protocol co-developed by Professor Christian Nansen and Dr. Ali Bab. Phase 1 involves controlled experimental infestation, with sensors inserted at 3 heights and 4 cardinal directions on each tree. Phase 2 extends this to commercial plantations under natural infestation conditions. The tree-level monitoring will be complemented by farm-level pheromone trap monitoring to capture population dynamics. Alongside sensor data, we will be systematically collecting in situ contextual data at each experimental site.
This includes agronomic practices, farm operation records captured through farm logbooks, and continuous microclimate data from weather stations. Crowdsourced observations will be captured through our citizen science mobile application. The first functional version has already been developed and supports geotagged reporting of infestation symptoms, ground truth imagery, trap counts, and farmer-logged farm operations. Together, these multi-source streams, sensors, agronomy, microclimate, satellite imagery, and citizen science, feed directly into the predictive analytics layer, which we will now take you through. Coming to predictive analytic, you've just heard about the rich multi-source data streams we are generating. Now, the task is to turn that data into intelligence through two linked families of predictive models: early detection models and risk forecasting models. Here is Professor Christian explaining our work about remote sensing analytics.
Presentation is to give a brief insight into how satellite imagery will be used in this project. I acquired some imaging data 3 years, from 3 years, 2003, 23, 24, and 25, from the same location. And I focused on Site 4 in the UAE. And now I'm going to show what's referred to as a false color image. So this is essentially the same field site, but now by using false color, we can much clearer identify the individual palm trees. So within this orchard, I am picking one particular area, and the reason why I'm picking that, and as a stock here, is it's very uniform. It's almost quadratic. All the trees are there, so no holes, and it looks very, very uniform. And if you zoom in even further, we can see that with this satellite imagery, we're actually getting somewhere between 70 and 90 pixels per day palm from that little study area. I did some processing, and I basically identified the 5% of pixels that are the most extreme, and then did that for the 3 years. The managers must have done a great job at this particular orchard, because there was definitely some stress going on inside the orchard and on this southern border here. Then in 24 it started dissipating, and then in 25 it was almost gone, and stress was almost exclusively restricted to a row of date palms out along a small road here. So this is a clear indication of management practices. Something is being done right. If we take this even further and look at the entire site, and this is for 2025, you can see that it is being certain regions are being highlighted as areas where there probably was at least some stress going on, and those would be the places that I think we as a team should focus on if we want to collect field data. But there are clearly other variables that need to be taken into account. It could also be something about irrigation not working properly. It could be something about the soil types, whether there's some contamination or some drainage, or basically some difference in soil types. It could be different varieties of date palms. And maybe even the age range varies in one area compared to another. So I'm in no way saying that this is a clear, we already have a signature of red palm weevil stress, and this is why we need ground truth data.
Okay, you've just heard how we source multimodal data and how predictive analytics transforms that data into early detection and risk forecasts. The next question is, how does all of this reach the end user? That's the role of the digital platform, which brings these components together into a single operational system. Functionally, the platform does 4 things. First, it ingests and harmonizes multi-source data: IoT sensor streams, pheromone trap counts, weather feeds, satellite and drone imagery, and citizen science observations. Second, it runs the predictive models to generate near real-time detection events, risk maps, and spread forecasts. Third, it translates these into actionable outputs: multi-layer GIS dashboards for supervisors and policymakers, and targeted advisories for farmers delivered via SMS, WhatsApp, email, and in-app notifications. And fourth, it closes the loop through treatment workflow management, so that every alert is tracked through to field inspection, intervention, and outcome. A first draft of the functional requirement specification has been completed, and an early working version of the dashboard, as you are seeing in this screen recording, is already operational, supporting plantation registration, Sentinel-2 vegetation index time series, and IoT sensor integration. The platform will be designed for multi-country deployment, ensuring the data privacy. Let me now briefly walk you through where we stand on overall workstream progress. Despite some early phase delays, Workstream 3 has made steady progress across all 5 outputs. For Output 3.1, the AI chatbot, activities were held up pending the UC Davis subcontract, which has now been signed, allowing full implementation to begin. Under Output 3.2, candidate field sites have been identified in the UAE and Egypt. 3 of the 4 IoT sensors have been procured and delivered, and testing protocols for Phase 1 experimental infestation are finalized. Sensor deployment was planned for March, but temporarily deferred due to regional travel restrictions. For Output 3.3, site prioritization is underway, and acquisition of very high-resolution satellite imagery is in progress, including engagement with Mohammed bin Rashid Space Center. Output 3.4, the digital platform, is actively under development, with the FRS and a working dashboard already in place. And Output 3.5, multimodal modeling, has commenced with open-source satellite data for unsupervised classification and anomaly detection. This ends our brief video presentation about Workstream 3. Thank you for your attention. We take this opportunity to thank our partners and donors. Thank you very much.
Thank you so much, Dr. Mukund, who is our Workstream 3 lead from ICRSAT, and also Dr. Christian, and all of the Workstream 3 team for the comprehensive overview of Workstream 3 of the program. So we now turn to Workstream 4 of the program. Workstream 4, Good Agriculture Practices, which forms the foundations of preventing red palm beetle spread through day-to-day farm and orchard management. So I am pleased to invite Dr. Muhammad Ali to present the key good agriculture practice innovation and also field practices developed under Workstream.
Thank you very much, Dr. Thank you, Dr. Mujib, and thank you all the audience. I'm Muhammad Ali. I'm a senior scientist at the ICPA, the International Center for Biosaline Agriculture in UAE. And ICPA is leading in this global consortium. We are leading Workstream 4, focus on good agricultural practices. And we are doing this work together with Workstream 5, that led by Farda. So hand in hand, we are handling these good agricultural practices. What do we do in this under this work stream, and why GAP? This is in this work stream we are focusing on the practices that are non-chemical, and here we mean those practices that are very essential for all the farmers, whether they are small scale, large scale, resource poor, or very advanced. These are indispensable practices that they have to be implemented. And some practitioners actually believe that if we have good agricultural practices only, then we'll be almost to solve half of the red palm beetle problem. They are simple practices at the field level, dealing with agronomic, sanitation, non-chemical methods. And what do we intend to do in this work stream? First of all, we want to assess how these practices, how they influence the station of the pest on the ground. But most importantly, we want to see how, as part of this consortium, we can make this GAP part of the management strategy of this pest. And as you can see in this famous triangle, IPM triangle, GAP represents quite significant part of the problem, because as mentioned earlier, the cornerstone of the IPM approach. Specifically, our task in this work stream is very clear, simple, straightforward, but very important. What we want to do in the beginning, we want to do baseline studies. We want to establish what's happening on the ground, what farmers are doing, how they're doing it, are they doing the right practices, if there are any gaps in implementation, what are these gaps, any barriers for implementation, and most importantly, how we can identify the gaps and then fill them through capacity development, developing learning capacity development tools. Okay, the baseline studies, we're going to collect data through field surveys. We're also going to do a number of instruments like focus group discussion, key informant interviews, and benchmarking. We are doing this work in 3 countries so far, in UAE, in different typologies, covering the line municipalities in the different regions. And this we are doing it hand in hand with the national partners, namely MOCA, municipalities, ADARSA, and others, covering 9 municipalities in UAE in more than 400 farms. Also, we are doing these baseline studies and also some of the field experimentation in Egypt. In Egypt, the work is in Al-Bahriya Oasis, in Aswan, and other regions. In Morocco, the focus is on the northern part of Nador and Tanja, where the best is so far linked there. It's not yet in the north, in the south, sorry. Okay. One of the first, on the main activities, what we are doing currently is we want to establish what is and what is the influence of the different agronomic practices. One of the most important practices is irrigation. How the different irrigation systems impact the infestation and the vulnerability of the palm trees. As you know, there are different methods of irrigation. We want to quantify what is the level of infestation in the different systems. And this is going to be very important, and I think it will be a very good outcome of this project, not saying red palm will be less in subsurface, but we want to quantify them and compare in the different systems. Another important also activity is the impact of the different sanitation practices. For example, the way the farmers, they cut the leaves, the pruning, trunk pruning, leaf pruning, the way they wrap the trunk or do painting. These practices, they have very strong influence on the management of this species. We want to quantify what is the influence of the timing of these practices and also the way they do it. The severity of pruning, the timing of pruning, we want to quantify and generate data on that. Another important outcome from this project, we want to also understand what is the combined influence of these abiotic and biotic factors on the infestation. We know for a long time, the dead palm has been part of an intercrop system. This is very clear, evident in many countries. In Egypt, Sudan, Syria, a number of countries, you find this on the right-hand side. Palm are part of an intercropping system, but in many regions of the Gulf, for example, Saudi Arabia, UAE, you find monocrops. We want to see how is the behavior of the pests in the different cropping systems. The influence of the variety. Also, yet until now, we don't have a clear understanding on the influence of stresses like salinity. Do we have more, susceptibility under saline environment? How is the influence of ground on the behavior of the pests? The habitat fragmentation also, how it affects the pests. We are only not limiting to studying the impact of the sanitation, the habitat, and the agronomic practices, but we want also to go further into proposing some innovative tools that we can put in the hands of farmers. And as I said, CAP is not dealing with large-scale control or chemical, but yet some of the tools that can be used for wound sealing. Wounds in the palm trees are part want to see if we can put in the hands of the farmers some of the very simple products that they can be used. We are testing the use of naphthalene poles, Tiomoron repellent that is available in the market, and some botanicals like neem. When there is an injury on the palm trees, we want to give a recommendation for the farmers to use this product for farm, but also in urban areas. Because in some urban areas, gardens or home yards, we cannot use chemicals, but we can safely use some of these botanical and safe products. We are doing optimization on this at ECP, at ICBA, sorry. Another also innovative technology we are now working on currently at ICBA, we are optimizing also a method of fumigating palms. Many countries, they import palm trees from abroad, and one direct method of treating protocol is through chemical spraying or dipping. We are optimizing a method based on ectofume. This is a novel chemical, relatively safe, 98% carbon dioxide, with only 2% of phostoxin. We are optimizing the dose and the exposure timing. And this technology, we are going to scale it and put it in the hands of our clients. When they import palms from abroad, the protocol is clear, treat with ectofume, suppose the seedlings at this dose, this time, they will be free. We are working on the optimization and also following the protocols for this intervention. The last component output of this project is on capacity development, and I think we would agree that we are talking about GAP, we are talking about farmers, and we have to really put this one as a central activity, and here we are focusing on developing protocols, standard operating procedures with clear guidelines on how to do the different operations when it comes to irrigation, sanitation, fumigation. This is part of our work which we are currently doing. We are also forming multi-stakeholder platforms involving different stakeholders, and we are designing different modes of interactions with them. We are also having e-learning modules, 4 e-learning modules focused on good agriculture practices. We are developing together with CARDA, modified farmer field schools to take the knowledge to the farmers, and we are also planning demonstration plots and different forms of interacting with the farmers. Last one is also this has to do with the policies, regulations. ICBA also, we are working on developing a protocol for certification of nursery to give the standard for production of seedlings that are free from red palm oil infestation, and we are developing clear guidelines, and hopefully this will be towards a proper standard, also to put in the hands of our clients on how to establish and to manage dead palm seedlings for production of this plant material. Lastly, deployment of our work at this work stream. As I mentioned, we are going to start with the baseline studies for very simple reasons. We are going to generate the evidence through these surveys, through experimentation at the field level, and also we are going to go for demonstration and capacity development. The policy is very important component here, either when we're talking about fumigation using ectofume or developing certified nurseries. And lastly, we are going also, this is going to be for scale-up through the development of the GAP protocols, the new tools we are developing, certification and the rest. And the work we are planning and doing now will focus on currently on UAE, Egypt, Morocco, but also a number of spill-over benefits are going to extend to other low and middle-income countries, and we have a list of them. So when it comes to protocols, capacity development, sharing knowledge, we have a list of low and middle-income countries. We are going to work with the other partners to see how we can take our outcomes from this project to benefit those
Thank you so much, Dr. Mohammed, for clearly demonstrating how strong agronomic practices reduces risks and strengthen palm resiliences. One request that I've got from our friends here that you are recording, that each presenter, if they stand here and present, that would be good so that everybody on the Zoom and online and virtual can see it. So with that, I am moving to the final 5th work streams of the program. So our final work stream presentation is from work stream 5, deploying pathways and policy. This work stream focuses on translating research outputs into field-ready, scalable, and policy-supported solutions, ensuring adaptation and long-term impact. So with that, I invite Dr. Hamatu to present the work stream 3 for you all.
Good morning, you all, and thank you for being here to attend this very important session on the red palm weevil. My name is Hamad Shahir. I am the technical lead of the consortium and also the lead of work stream 5, which is actually consists of 3 work packages. Work package 1, which is concerning socio-economics, and work package 2, citizen science, and work package 3, the deployment pathways. The work stream 5 is about translation of research into action. And as you know that the red palm weevil has been in the Gulf area, spread from Gulf area around the world during the last 40 years. And the actual research on this weevil started 10 years later. And then from that time, the research start to go or start to be concentrated on this weevil. In this research to action. The important thing in this work is we are trying to follow a new paradigm, a new approach in the pest management. As you know that the pest management, there is a problem, particularly with the adoption of the IPM at the field level. And the reason is that because there is a high complexity at the field level and people are not considering that. So they are applying different technology in this complex environment, and the results in this case could be either synergistically, this technology could act synergistically, or they could act also antagonistically. And they can be also neutral. And in this group, we are trying to adopt the new paradigm, which is multiple dimension of multiple pest management, or they call it 3MB. And this paradigm, this approach is a holistic, depending much on synergy, just making the synergy among the different technology being applied in the field simultaneously. And this holistic approach we are adopting in this work stream. Next. The objective of this is to, as I said, is to translate the science, or translate scientific things into action. And the approach we are going to follow is the participatory approach. The participatory approach, the importance of this approach is to involve the farm from the beginning in the implementation. And this is actually what we did in this work stream. We start to deploy the technology together with the farm, so that at the end of the day, they feel that this is their own technology, and they can adopt it. And this participatory approach also involves other stakeholders. So that, like, also private sector, the farmers, the community, and all these stakeholders to be involved together. Next slide. This is the progress so far we have made. We just specify like 36 farms throughout UAE in different sites, and we selected different typology. We started with the coastal area or the Abu Dhabi area, and then we selected also farm from the central part, this Central Emirate, the 6th Central Emirate, and then also we considered the highland, which is represented by Fujairah, some part of the Fujairah, where they are the highland. And we consider this type of typology, this type of different ecosystem, ecosystem, because we are expecting the boundary we are going to test to perform differently in this area. Because as you know that there are different climate and different typology, and also different ecosystem, and also different norms, and some kind of the practice exactly applied by the farm. So within this identified farm, we have just put traps, drive traps for monitoring each trap in one farm to monitor the population and to have a baseline study so that we can start from this baseline study. The same we did in Egypt, but the number of farms there are less if you compare it with it. And at the end of the day, we are using UAE as a seedbed to test all this kind of technology, and when proven effective and cost-effective, environmentally friendly, and also socially accepted or accepted by the farmer, then we'll take them and try them in different countries or limits country, the country which are being affected by the red palm. And I think this approach is most important approach. Next slide. Okay, I'm going just to narrate some of the success we have made. I will start with successful reading of red palm weevil in large colony. We started in this group to work in Hamraniya, and you know that Hamraniya was a lab for research on the red palm weevil. An old project about this lab, which we are working on the biological control, and there was no work in this lab for so many years, and we selected the area of Hamraniya to be as a hub for the whole project. And I was always saying for the people that the red palm weevil was first discovered in Ras Al Khaimah in 1985, and then the red palm weevil just came back, and the control or the management of the red palm weevil also start from Ras Al Khaimah or from Hamraniya. What actually we did so far is the testing the efficacy of subsurface irrigation, how the subsurface irrigation can manage the red palm weevil. As my colleague Ali said, there was no empirical data on this, but we did an experiment in Hamraniya and testing 3 types of irrigation: the flood irrigation, subsurface irrigation, and drip irrigation. And we came with a numerical data with some statistical analysis that the subsurface irrigation is more efficient and very suitable for the control of the red palm weevil. You can see also here in the picture that irrigation should target the root zone. There is no need to flood irrigate because the root of the date palm, they are concentrating, or this white root, they are concentrating in the first 30 centimeters. So there is no need to irrigate on the surface. And this irrigation on the surface is inviting the red palm weevil to come. How do you know that the red palm weevil is humidity loving insect? So usually they love the humidity, and this is also based on the composition of the cuticle of this insect. I'm not going to go in much more these technical details, but they have the wax over the wax. They are very fragile and can be very affected by the dryness. So it's why always when you find an insect, it will try to hide itself and try to find this humid area. I think this, you can see there in the graph, this surface irrigation, there was zero infestation in that. Although we have some other, we find the infested palm, and even this infested palm were severely infested, and we roke them out and we remove them. This paper is published in Outlook of Pest Management, and it is available there. And this is maybe one of the first work to be carried out on this subset irrigation effect with empirical data. Next slide, please. Yeah, here also, I came just by chance in one farm, and I found that they are hanging kerosene. In that photo you can see on the right, hanging kerosene, and they claiming that this kerosene is repulsive, or it is usually repellent for the red palm and other insects. So we took that and subjected to scientific testing. And we designed an experiment also in Hamraniya to see whether this claim is true or not. We brought the Tumoron, a repellent, which is commercially available right now, and this Tumoron is produced by Kentica. And by the way, I am the one who just contributed in the production of this Tumoron when I was in the King Faisal University. We worked together with Kentica International, and we produced this Tumoron, and now it is commercially produced. We make just experiment, as you can see, this experiment, or this approach, you can call it trap shutdown. We put the pheromone and pheromone, and then we change this pheromone and pheromone by putting the diesel or kerosene, and then in the other treatment we put Tumoron. And we just start to record the data for 3 weeks or for almost 2 months for this weevil. And you can see here also the result is very clear. We captured no weevil in the Tumoron, and then you can see also here the diesel is not working. Yeah, it's not working. It can give some kind of repellency compared to the control, but it's not that thing. And also I asked some of the farmers, at Mansour, who appeared in the video you have seen, I asked him, what was about your opinion in this kerosene? And he said, I tried it, but it doesn't work. Without knowing, when we started the experiment without knowing any idea about this, whether it is working or not. So this is one of these important things. The paper now is accepted also in one of the journal, and will appear soon, just 10 days. Next slide, please. Okay, this is the conclusion of my talk. I want to say one message. The red palm weevil is not a wicked problem. It is an insect that can be controlled, because some of the people around the world start to be desperate, saying that, oh, this is a wicked problem and cannot be solved, and this is all just waste of effort and waste of money and not be controlled. But the red palm weevil could be controlled easily if we just have all the stakeholders coming together, particularly the farmer, to be engaged. If you have the political support, for this, we have the resources for this, and we have the coordination. It needs a very high coordination. And then among all these stakeholders, and they need consistency. It should have to be continuously monitored, because if you know that this window, if you leave it for 1 month, then it will reinvade the area. It will reproduce, because the last effort during the last 40 years was people control the red palm oil and then stay for 2 months, relaxing, and then come back again and so on, and will be in this vicious circle. We cannot go out of this vicious circle unless we have a new approach and a new paradigm. And this is we are going to test here also. We are going to start with breaking the population. So if you have an enemy and you can break it down into small pockets, so you can conquer it and you can win the battle at the end of the day. Otherwise, you cannot control it if it is a large population. Thank you very much for listening. Yeah.
Thank you so much, Dr. Hamato, for highlighting the critical role of integration, stakeholder engagement in policy, in moving the research forward into action. So with that, our presentations have ended, and after the presentation and we have a coffee break, and then we will be here back at 11:15 sharp, and then at 11:15 there will be a panel that will take questions from you all, and also questions from any of our colleagues that they are online in Zoom. So prepare your questions and come ready, and the panel will be led by ECARDA's Deputy Director General for Research, Dr. Augusto, with our all other panel members. So come back, let's see you all at 11:15 in this room, and come with your questions if you have. Thank you so much, and see you soon.
جالسين شلون صوته منيح؟ ته هي سا تشي ما هي دو هي ته او س اوكي Yes. Yeah.
الو وعلى درعون ريلي test. Hello, test. وعلى درعون test.
1, 2, 3, 1. 1, 2, 3.
Hello, hello. Hello? 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 Hello everyone, I think we can go ahead and get started. If you can please have your seats. We will go ahead with the panel discussions. If you can please have your seats. For the panel discussions, we have So for the panel discussions, we have Dr. Augusto, ECARDA's Deputy Director General for Research, so he will be chairing the panel. And then the panel members, I want to call on Dr. Samira and His Excellency Mubarak Ali Al-Mansour or his representative. And then Dr. Muhammad Ali Bab. And Dr. Hamatul. Like I mentioned before, the panel is really to answer any questions you have, but Dr. Augusto will take the floor and then set the stage before questions are asked. The floor is yours.
Thank you, Mojib. Thank you everyone for being here today. This is an important event for Ricarda, for the partners, for the presidential office. This is a project that is a landmark of innovation, science, and also to make sustainable the production of dates in the region. So we have a distinguished panel of members. Thank you for being here to discuss how is the Red Palm Weevil project bringing the science that is needed to stabilize the production of dates, but also to resolve the issue of this very important constraint to the production and of the dates, and how you, as scientists and the partners on the ground, see this project contribute further to resolve the problem. So, and I would like to thank you all, and if you accompany me, I would like to start with Dr. Samira, who is bringing the component of trying to bring the biological solutions, semiochemical solutions to make sustainable not only the production of data, but to make it more safer, cleaner, greener. And so, please, can you, from your perspective, how the project is actually benefiting not only this solution, but the perspective in your research group to go even further to solutions in other places where you operate?
Thank you so much, Dr. Augustus, and thanks to all of you. Okay, from our own perspective, as has been mentioned, there have been so many initiatives before us, but they have been either working on silos or in isolation. So this particular consortium have the strengths of working together, working from different perspectives, from our own perspective. Having bio-based solution and resilient, we are coming up with various innovations. And in our innovation, if you have to win a battle against any, including the pests, you need to target each and every stage of the pest for maximum gain. And this is exactly what we are doing. And what we are developing, it is very in line with the donor strategies. It is in line with our own strategies and with the carbon strategy, not forgetting the farmer perspective. The farmers, they have been working on this space, they have their own intellectual, and we need to bring it on board. And this is, we take it, we don't take it lightly, we take it with seriousness, we work with them very closely, and we are building on our knowledge from other by control program that have been implemented, and they are very quite successful, whether on fruit fly, fall armor, and others. And we are using the same approach to tackle the red palm oil jointly with the other member of the consortium.
To my next panelist, and from the perspective of the partner here in the UAE, and we are very grateful, by the way, that you know, ADAPSA and others has nominated the farms in which we are going to be testing these technologies. And from your perspective, how do you see, you know, our participation and active involvement in the region, you know, helping you making decisions beyond what is currently in place?
Thank you all for welcoming me, and thanks everybody. Our Emirates of Abu Dhabi in here, we're doing intensive identification, detection, direct control, and sanitation. With your involvement, I think we can be developing new ideas, especially technologies. I was amused with the modelings, and I'm looking forward for more innovation in this. We acknowledge are the best people to do that part in IPM, and this is more exciting for us. We met Dr. Hamidou, with Dr. Habib, we came to the farms. They are doing a bunch of bundles, and even the farmers are more participating, taking interest in it, and we're looking forward to more, and to work together, give good outcomes.
So okay, so this is actually, there are a couple of things I'm going to follow up you, but one of the things that I'm picking up now is the excitement of the different partners, right? The farmers and the scientists, you know, to get involved, to see more of these new innovations coming in. So, and then Dr. Ali, from the perspective of the good management of the palm farms itself, you know, how much, from your perspective, is the research that you are conducting now in ICPA is helping to position the best practices of farming dates as part of the solution for the record?
Thank you, Dr. Augusto. And before I answer your question, I'd like to mention that I happen to be part of a previous project led by FAO on eradication of red palm oil in the MENA region. That was a big initiative, and we were targeting a number of interventions. And looking at what we achieved in that program and the current consortium, I think we are lucky because in this consortium we will learn a number of lessons from the previous intervention in that project and also from other programs. And the way this project has been, this consortium has been constructed, the partnerships, the planned activities, the level of fundings, these, to me, they are way more advanced, and they are really positioned to help much in the fight against the red palm oil. Look at our partnerships at our national level. For example, here in UAE, we are working with those partners who are really doing the work. With BOCA, with ADAPSA, the municipalities, we are doing the work hand in hand with them. We have been in active discussions with them in those institutions, and also partnerships at the country level. Also, we have very clear activities on what we want to do with those partners, and with full involvement of all of us. So this is again, I believe, the way we have The governance, the way we are also following as implementing on the ground is also very good. I also should say that the level of support, it is reasonable what we expect to do in this consortium. Having said this, let me say for GAP, as I mentioned in my presentation, it is a cornerstone of prevention. And the beauty of GAP is that you need it if you are a small farmer or you're a high-tech farmer, it is indispensable, you have to do it. In this project, we are working on GAP first of all to generate evidence, to generate empirical evidence on the influence of the different GAP on the pest infestation and the health of the plant. This is something very good because we are not going to say the red palm will be less under subsurface irrigation. We want to see a comparison in figures. This will be a very good outcome from this project. We are also not doing it in UAE. We are doing it in a number of different hypotheses, and we are going to validate it in different ways. Thirdly, we are not only stopping here in this project and establishing, but also innovating some more tools, like wound sealing. We want to provide some innovative products that we can put in the hands of the farmers. When you have an injury, use this tumor, straightforward, non-invasive, not expensive, or use this knee, naphthalene oil. Again, we are also having another innovative technology to share with our stakeholders in the country. You import a shipment of dead palm from Iraq, comes at the border. You need a protocol how to deal with it. Are you going to dip it? Are you going to keep it? No, we are giving them a protocol, and this is a very important outcome that will come from this project and going to be part of GAP. I believe as we go along, we are going to put more innovative tools to be part of GAP. Like maybe 40 years back, GAP was talking about A, B, C, D, but with progress of time, outcomes from this project, we are going to put some innovative tools to be part of the GAP in the hands of farmers. And I think this is what we are trying to do at ICPA and also hand in hand with all the stakeholders in this project. Thank you very much.
Thank you, Ali, for this side. Dr. Hamad, as we move into scale, right, and testing for the technologies that are going to be most important in terms of providing solutions. So from your perspective, you are in the intersect between innovation and scale. So what is the lesson learned from the implementation of collecting that basic ground data that will validate the application of different bundles, as you described in your presentation, for providing farmers which are participating in this program a vision and an opportunity for resolving the problem of red palm weevil here in the UAE.
Thank you very much. I'd like just to say that this consortium is unique in one thing. It is about unifying all the global efforts in one just consortium to avoid the historical fragmented efforts which has been applied. This is one thing, and also other dimension of this consortium is to concentrate on socio-economic impact of the red palm weevil, because this part is also very important. Not only technology will just handle the red palm weevil. You need to take also in consideration the socio-economic aspect, and also other things which is maybe also in addition to what has been made, is to include the citizen science as a new concept. And this citizen science is to involve the citizens in the collection of data and involvement of the red palm weevil management, because you know that amenity farm in some of the houses here, I've seen some houses have like 200 trees. So it looks like a big farm, even in the house. And these are
are not being taken care of by the authority or the Red Palm Weevil control, because they are assets of citizens. And in this case, they will be like a refuge, or will be like a site for the Red Palm Weevil to invade the farm or the other farm. So this project is considering this, and we have also activities under the amenity farm. We also are going to take care of the ornamental farm, the roads. You go here in Sharjah and some other emirates, you find a lot of date palms around the highways and around the state. Also, they should have to be controlled in order not to jeopardize our efforts there and not compromising our efforts in that one. Actually, we started at the beginning of this project to categorize the technology available around the world into 3 categories. The ready-made technology, or the technology that can be immediately applied in the field. They call it technology readiness level, like 8 to 9. And then other technology like 3 to 6, other work streams are working on it to develop it to reach the stage of 9 or 8, then we can deploy it in the field. We just follow this approach because the Red Palm Weevil cannot wait. So we can, in this consortium, we cannot wait until the 3rd year or 2nd year to have technology coming out from our project, and then we deploy them in the field. So we started with the existing one, bundling the existing technology, so that we can keep at least the population of the weevil at hand. And then we are waiting for technology, new technology to come out of this project, and you have seen from the presentation that we are expecting innovative methods and innovative technology to come out of this. And once they are ready, we will take them for field testing, validation of very fast validation, testing, evaluation, and then when proven effective, then we can deploy them in the field. And I think in this way also will involve the farmer in the deployment, so that they will feel they are part of it. And at the end of the day, they will adopt it, and they will not say, no, we are not adopting it. Thank you very much.
Thank you, Hamadun. As I return back from you to the first speaker, I would like to touch on now the challenges, right? And then you mentioned one now that is quite important, which is policy. You know, how the enabling environment, whether it's the government or the associations or anybody that has decision-making power in terms of creating the governance for tackling the problem is acting. And so how is your now data, if you're collecting data on the ground, whether it's in the farms that have been kindly provided by the UAE or the monitoring across the region, how do you see the project and your work influencing policies so that these actions are part of the day-to-day decision-making process from the policy perspective?
Yeah, thank you. I think this is a very important thing in the whole management of the Red Palm Weevil. Policy and regulation. So we need to have this very strict criteria, internal and external criteria measure for the Red Palm Weevil, and also the movement of the palm from one place to another. We know that there are laws, there are rules in all countries, but the application of these, strict application of these rules, it's matter, it's very important. And in our work with our partner, whether in Darsa or Mocha or in Egypt, also ARC and ARC, we are stressing on this. We are talking always about this regulation to be put in practice. And I remember also this is that Mansouri was speaking with me, that's from Rasa team who appeared in the video, telling me that I'm doing everything on my farm, but the Red Palm Weevil is coming from my neighbor. They're not caring about it, and even they're not allowing somebody to enter it. And he was asking me, please, in this consortium, in this project, try to speak with the authority there, these people who are concerning the Red Palm Weevil management, to make a law or to make rules that every farmer should abide by this rule. Every farmer should open his farm or the team of inspection environment. This is very important, and this should not be the choice of the farmer. This should be governmental regulation. Anybody should respect, coming from the Ministry of Agriculture, or coming from MOCA, or coming from any agricultural body who is responsible for the red palm oil. This is, I think, very important, and we are working on it. And in the consortium also we have activity on these rules, which will be held by the socio-economic work group. And we are not going to change the laws, existing laws, but we are going to propose some of these laws, and we see the authority now is trying to see if you can adopt these, and if you can modify laws to be this way, that would be very nice and would be very helpful in the control of rate. Thank you.
So if we go to now the best economic practices, how to prevent, because prevention to me is a very important component of the response to the diseases. How do you see you again in the innovation environment? Because you were saying in your intervention that there are so many other innovations and technology that could be applied. So when it comes to scalability, so how you see the role of the gap in terms of creating this space for confidence that those solutions can be scalable?
Okay, one area of intervention as far as what stream 4 gap is concerned is also linked to your previous question on policies and regulations. We know that the main 4 pillars of IPM of red palm oil, one is about the quarantine regulations to prevent, control the movement of farms. Another one is related to certification of plant material. And the third one is about detection. Fourth one is about what are the actual interventions at the field level, being pheromones or removal of infested palms or whatever. The fifth one, is capacity development. So you can find almost this gap in at least 3 or 4 of them. If I may name a few, like on regulations, we are developing standards that we are developing together with the national partners for establishment of certified nursery for production of free RPW free planting material. It should be a very important instrument in the hand of the national programs to help them. Secondly, also, we are developing also in our protocols, GAP protocols, there are also guidelines regarding the phytosanitary regulation that will be part, and this is what we need hand in hand with the socio-economic team of ICAR. So we are there in both. Okay? On capacity development, of course, is a very important activity of our work streams. The tools that we hope to put in the hands of farmers is we are developing optimizing some tools that can be used for wound sealing. As I mentioned, one of the biggest problems is that this wound, whenever you have a wound in a palm tree, definitely you invite an infestation. No way. So I don't want to let the farmer spray X or Y or Z chemical. No, use this naphthalene ball, it is a repellent. Very cheap, available, put it, and it will repel it. Or use fumarole, commercially available product developed by Hamad and his team in Faisal University. Now in the market, use it, hang it on the tree, it will repel the insect. Or use botanicals, that's neem, very safe, very cheap. So these are some of the tools that are simple, non-invasive, destructive to the environment that we can put in the hands of the farmers. I also mentioned about the protocol for sanitation of palm trees. So these are some of the innovative technologies that we can take right away and put in the hands of the producers. Most importantly, this project is also concerned with low and middle income countries. And the good thing is that some of our tools are affordable and they can go right away to help those in need in those countries who cannot afford advanced technology, but they need some of those simple tools to help them fight this pest. Thank you.
Thank you. your perspective, how do you see this project contributing even further to sensitize not only the importance of the control of the red palm weevil on farm, but the access to the farmers, to the scientists that are actually bringing those technologies and those solutions into realization. So how do you see this bringing value to the UAE?
Because it's eye-opening. I'm gonna make it very short. It's eye-opening. Like many people, they're trying to get in sustainable agriculture. They want to make their farm more commercial, and for themselves, can make it environmentally friendly, socially accepted. So when we get like something gonna benefit us, especially environment-wise, health-wise, it's like okay, I want to try this one. I want to see if it's gonna work for me. Okay, we have many different types of date palms, many varieties. Might not work for some, but for some it might work. That's in that case. I'm just giving a small, simple answer.
Great, thank you. This is one of the added values of the Red Palm Weevil project in operating in UAE. Farmers see firsthand how science can actually bring solutions, right? And this is and then new innovations. Then I would like to close my end. I would like to open the floor for others to ask to the panelists. From my perspective, Dr. Samir, as you bring new technology, you're in the forefront, you're in the R&D 1 and 2. When you are bringing these new solutions, and they have to be scaled, right? So you are interacting with biological entities that could potentially be not easy to transfer or to adapt into the conditions of different countries you're operating. So how do you see yourself moving forward with your portfolio?
Your question is very important. Here we are dealing with mostly with biological material. And you see, as you said, first of all, their efficiency will vary across ecologies. And again, vary across even populations. Probably we have different population across different countries, and they need to be tested. And here also policy comes. Because we are dealing with biological material, we need regulatory body, and sometimes they can be very cumbersome. Let's say importing a person, let's say from Brazil to any Chinese countries have their own regulation, and if those regulations are not harmonized or will be a bit flexible, then we will be having difficulty importing just by controlling in different countries. Some countries, they even treat the pesticide as a chemical, synthetic chemical pesticide, they subject them to very rigorous regulation, which is not supposed to be the case. These are all of those organisms that are quite specific, and they don't harm even if it is a similar tax. They are quite specific, and they need to be treated accordingly. For me, once we get the enabling policy, I see a lot of prospects for these natural enemies, whether they are in the buzzweed or in the fungi or even natural enemies. Reason being, as I said, they are quite specific and they are climate resilient. Most other interventions, they can be affected with the climate change, but this one, they adapt climate. So I see they have a lot of prospects, and by the end of the project, inshallah, we'll be able to at least to validate them in the field and hoping to upscale them on a big class and most important area. As Ali Ahmad mentioned, if I implement this one and my neighbor does not implement it, then the impact will not be that much. So we're hoping for an area-wide approach. Thank you so much.
Thank you very much. And I would like now to open the floor for questions to the panelists. And please, the floor is yours now.
Yep.
Yes, there is one question here, please.
Thank you guys for your panel discussion. Really interesting things that we've been talking about all day today. My question is, I'll ask my question in Arabic if that's okay to Adapsa, and please answer in English or Arabic. But نحن قاعدين نستثمر وايد في هذا المشروع، وهذا شيء جدا مهم لنا من ناحية what does success look like? Let's say that we completed this project, now the partnership is over. What does success look like? Please feel free to answer in English or Arabic. Thank you.
فدفسة هدفنا نحافظ نكون جزء من الأمن الغذائي، الأمن الحيوي، ونرفع كفاءة المزارع والإنتاج المحلي. في انتهاء المشروع، واللي خلصنا المشروع شو بيصير على قدام؟ أتوقع توفير البيانات جاهزة بتكون تكنولوجيا جديدة بتساعد في تخطيط المستقبل الحالي، خاصة مع تغير الأجواء، تغير الطقس، مرة درجة حرارة مرتفعة، مرة منخفضة. على السنوات الماضية على تغير الجو الحرارة ترتفع فجأة والشتاء يطول شوي، فهذا بعد يتدخل في الأمن الحيوي. اعتمادنا الكبير على النخيل يصير شوي على ويشتغل، بس تركيزنا المهم والأساسي والركيزة هي النخيل نفسه. فأقول إذا انتهينا من المشروع واللي بيكون معنا هي البيانات المتوفرة واللي هي بنبني عليها استراتيجيات المستقبل.
السلام عليكم ورحمة الله وبركاته. حياكم الله جميعا. شكرا للحضور البانيلست. تعقيبي على سؤال الأخت فاطمة مكافحة سوسة النخيل الحمراء هو عمل جماعي يجب أن يشترك فيه المستوى الاتحادي والمستوى المحلي. يجب أن يشترك فيه كل الشركاء الاستراتيجيين، سواء كانوا مشرعين أو كانوا دوائر ذات مسؤولية خاصة باللاندسكيب اللي تكلم عنها الدكتور. النخيل التي تقع على الشوارع الزينة التي تستخدم بالزينة يجب أن تكون تحت السيطرة، ويجب أن يكون في تشريعات تضمن تنفيذ البرنامج بشكل دقيق وصحيح. يجب أن يكون هناك مشاركة من الريسيرش، من الأبحاث. يجب أن يكون تركيز على حفار الساق، مثل التركيز على سوسة النخيل الحمراء. يجب أن يكون هناك تدريب، يجب أن يكون هناك توعية، يجب أن نتعاون مع قادة المجتمع الزراعي ونقنعهم بأهمية تنفيذ المطلوب منهم. انتقال الآفات من مزارع مهملة إلى مزارع معتنى فيها، هذا يجب أن يوضع له حد ويوضع له تشريع يضمن عدم اللي هو انتقال الآفات من المزارع المهملة إلى المزارع العامرة والمزارع المنتجة
اجتماعية ينضم فيها جميع المعنيين في هذا المشروع. أتمنى لكم التوفيق وجزاكم الله خير.
Thank you very much. If I may just add a few. Okay. I think one of the good thing in this project is that we are, as I mentioned earlier, we are working with the partners in the national programs, because we are not putting ourselves as international research institutions, and we are going to come up with our solutions. We know very well that in UAE, ADAPSA, in Egypt, in Morocco, these national programs, they have very rich experience on understanding the situation, on dealing with the pest, and they have also been working for years in developing and adapting solutions. We are not just coming and to work in isolation. Whatever we're going to do is going to be hand in hand, and we are going to build on the rich experience of those national programs. If I may name one, it's going to be ADAPSA in UAE. And for example, we are developing protocols. We are not starting from scratch. ADAPSA has developed protocols. We are just going to see with them how to complement them, how to add another aspect similar to populations. In Egypt, they have also very rich experience, so we are complementing the efforts that have been going over the years. Morocco, they have rich experience on dealing with ornamentals, so we are trying to benefit from those ones and complement them. The beauty of our consortium is working hand in hand, but I should stress, let us make this one really effective, not just saying, but we want to make sure that we really work with them and find solutions. This is very difficult, but that one very much in our mind. You raise very important issues about looking at all the spectrum, not farms, but looking at amenity trees on the streets, closed farms. Those are potential breeding sites. We don't consider them through regulations, through intervention, guidelines. We are going to lose the pattern because we control here and we fail there. These are very important considerations, and they are very much in the mind of the leader of this program, and hopefully we are going to work hand in hand to address those ones. Ornamental, breeding sites, palm from the streets, dead palm, all these ones are in consideration. But we need to make it more effective our partnership and potential at the farm level with the national programs. Thank you.
السلام عليكم. بسم الله الرحمن الرحيم. في البداية أولا أشكر جائزة الخليفة الدولي لنخيل التمر والابتكار الزراعي على إجراء هذا المؤتمر الدولي الثامن نخيل التمر، وأشكر جميع الخبراء الموجودين اللي تحدثوا عن السوسة الحمراء وخاصة إيكاردا. في البداية أود يعني قصة السوسة الحمراء. طبعا السوسة الحمراء أول ما بدأت في سنة 1985 في المنطقة الزراعية الشمالية اللي تابعة لوزارة الزراعة والثروة السمكية في منطقة يسمونها خد ومنطقة دقدارة. هذه بداية 85. فطبعا من بداية ظهور هذه السوسة ما حد كان عارف شو هذه الآفة أصلا. فبدأوا يقوم بأخذ 3 عينات وتم إرسالها إلى روث هامستيد إكسبيرمنت ستيشن. حتى خاطبت أنا الملحق الثقافي البريطاني، مريت عليه وقلت له أنا عندي سوسة أبغي نرسلها علشان تصنيفها. فقال لي نحن ما ندخلها مثل هاي الآفات بلدنا. فعن طريق أنا كنت أعرف واحد اسمه فيليب جون خبير في روث هامستيد إكسبيرمنت ستيشن، وأرسل لي 3 عينات وتصنفها ورجع لي واحدة. يعني لهي الدرجة اللي كانوا حريصين. ومنذ بداية السوسة طبعا مثل ما تفضل زميلي الأخ مبارك المنصوري، طلعت قوانين وتشريعات وقرارات وزارية بمنع استيراد جميع أنواع النخيل وأصناف النخيل، جوز الهند، من زراعة أي حاجة متعلقة بصنف النخيل. فطلعت قرارات وسوت اجراءات وجينا خبراء وربينا هذه السوسه في المختبرات. وكان ايضا في مختبر تابع للمنظمه العربيه للتنميه الزراعيه في منطقه الحمرانيه بتمويل منهم وتمويل من الصندوق الاسلامي في السعوديه، وقاموا بتجارب عديده، وكانوا هناك مهندسين زراعيين موجودين، وكان عندنا خبراء من كندا ومن المكسيك، وايضا احد الاخوان المهندسين ايضا الاخ منصور كان موجود. بس ولكن مع الاسف يعني تدوين هذه المعلومات ما ادري وين صارت، واذا كان احد من الاخوان عنده اي فكره عن النتائج اللي طلعت، وصارت براءه اختراع لهذه مثبتات السوسن. يعني ما ادري اذا كان اي واحد عنده، لان تعرف الوزاره انتهت، وزاره الزراعه وبعدين سموها وزاره البيئه والمياه، والحين وزاره التغير المناخي والبيئه. فهذه الجهود وبذلت جهود عديده، وصاروا عده مؤتمرات وعده نشاطات وعده اختبارات على هذه السوسه، وطلعوا قوانين، حتى قوانين الحجر الداخلي كان موجود، وفي قوانين موجوده بعدم استيراد حتى من دول مجلس التعاون الخليجي. يعني كان في تشريعات موجوده، بس ما ادري اذا كان حد عنده فكره. ما صار في نتائج المختبر اللي كان تابع للمنظمه العربيه اللي كان موجود في محطه التجارب الزراعيه في الحمرانيه، كانت هذه موجوده، والنتائج مع الاسف يعني كانت نتائج جيده واستعملت يعني. فمشكورين وشكرا على الانكار على الخبراء الموجودين المعلومات المناقشه. شكرا.
شكرا جزيلا على هذه الفزلكه التاريخيه وهذه قصه اكتشاف سوسه النخيل الحمراء. عشان كده في كلامي اللي قلت انه نبدا ما اكتشفت السوسه الحمرانيه، وفي جهود ذكرتها تقريبا بتاع المنظمه العربيه وما تم من انجاز في مكافحه السوسه، بالاخص مكافحه البيولوجيه، استخدام النيماتودا، استخدام الفطريات المنبضه، الفيروسات، حصل تقدم كبير جدا كان، لكن للاسف ما حصل تواصل. ودائما انت ذكرت انا بحثت عن بعض الايسوليتس، بعض العزلات الموجوده من البكتيريا وما يعني تحصل به هذا المشروع، لكن للاسف ما وجدناها. يعني ما وجدنا العزلات اللي كانت موجوده، سواء كانت من النيماتود. بحثنا في هذا البدايه، انا شخصيا بحثت عنها ما وجدناها، لكن معي التقرير، يعني معي التقارير كلها في المشروع. لكن حاجه كويسه انه وجدنا بعض التجربات اللي هي بعض السوس الميت هناك وفيه البابيريا، وانا اظن ان هذه البابيريا من العزلات اللي كانت وجدت قبل كده، وحنبدا من هذه البابيريا. هذه يمكن الدكتوره سميره حتبدا منها، عندها تيم حيث ان شاء الله في العام الجاي، وحيبدوا في مساله البيولوجيكال كنترول، وممكن يبدوا من البابيريا والاكسوليت اللي كان موجود. شكرا جزيلا، بارك الله.
المشروع اللي حكيت عنه هو كان بتمويل من المنظمه العربيه ودوله الدونر، واستمر لسنين طويله وكلف حوالي 10 مليون دولار، وكان بمشاركه 6 GCC countries، وكان عنده 2 ريسيرش ستيشنز، واحده في الحمرانيه وواحده في القطيف في المملكه العربيه السعوديه. تركيزه كان على البايو كنترول، ودورينج ذات تايم حتى هم عملوا امبورتيشن لوان اوف ذا كينيت باراسيتويد سبيل استخدام ترانكولايز. Unfortunately, after 10 years, after 10 million expenditure, and a number of isolates of nematodes, entomopathic fungi, but there has been a gap. And many years have gone, and now we don't know. There is no problem. Yeah, there are reports, but there has been long gap, no activity, and no continuation of that program, which now has been part of the in the Tanzania research station.
As mentioned by أتكلم بالعربي ولا بالعربي؟ عربي؟ أوكي. زي ما قالوا الزملاء we are not going to start from scratch. All what you have done is very valuable, and we are going to do baseline survey both on the ground and also talking to people who have already worked, some like who are dancer. You have done a valuable work, and that can make the foundation of whatever we do. Thank you so much.
Samira.
Thank you very very much. My name is Mahmoud Douairi. You know, we know about the losses now. Thank you for, bringing us today on the losses. We understand the numbers. So we did not have, we did not hear two things. What percentage is lost? And more important, how many millions of dollars? I think, we should know what is this loss? $60 million? 30%? We really need to give figures. May I have figures, and maybe, we should have a table. What are the losses in the United Arab Emirates, in Saudi Arabia, in Sudan? I think, once we know the numbers, then we say, oh, too much. Why shouldn't we do something? I think, we as agronomists and plant pathologists, we should teach people to become aware about the amount of losses. They don't care if it's 10% or 3%, but if you tell them it is $1 billion, they will start scratching their heads and they will say, we will give money and we will do this. Thank you. Maybe we have to hear some numbers.
I think the importance of this research is not only just on the current losses, but this pest is very resilient and adaptable to climate change. So it could upramp as a part of the adaptation cycle so that it could actually wipe out the whole industry. That's how aggressive it is. So I agree with you that numbers will, mobilize people's interest, but also what is bringing this consortium into life is that what we want to do is with the knowledge that is being gathered from here, because I agree, there's a lot of knowledge being gathered in the region about how to control the pest, how the society reacts against the pest. And now what we want to do is, with this knowledge, to go to the low middle-income countries outside the UAE. So the UAE is benefiting from the exercise. We're trying to rescue all that information. But what we know about the pest is that this pest can outbreak to a level that can actually wipe out complete industry. Oil, palm oil industry, can wipe out the day palm industry. It's very aggressive, it's very adaptable, and if we know more about it, the better we're going to be equipped. So that's how it works.
I agree with you. Number is very important, and then there is some statistics. So whether it's Saudi Arabia or Emirates, they are like, but it is more than numbers. The dates and Nakhil, people are so much attached to Nakhil. It means so much to them. A destruction of, let's say I am a farmer, and I have only five people. Destruction of only two, those ones. It means so much to me. Not only a source of income. People attach so much value to it. It's a blessing. So I don't even want to lose one. Thank you.
First, I believe, let us be frank, in the strategy for red palm oil management global, I think we lack this aspect of the social economy. We don't have clear and validated figures on the economical impact of this space. This is a real, and it is very important for policymakers, for investment, for a number of reasons. Ideally, we should have clear information about what is the economical impact of this space. This is to me, I'll tell you, it is lacking. Recently, there have been some studies from Egypt and from Saudi Arabia, but those ones are not conclusive. But also we don't have information about other countries. Another also serious area where we lack information is the availability of data on infestation levels, almost across the country. And without reliable data, then there is a major drawback in our strategy. And as I always say, if you cannot measure it, you cannot manage it. I have been in the field for the last 20 years. I don't know of any country which has maybe a few examples, but largely we lack data, good data for distributed energies across the countries. So these are some of the areas we need to improve.
I would like to follow up. Sorry. Okay. With I agree with what you're saying. I want to add, no farmer wants to say how much he lost. Okay. We have this problem also with the farmers. We do some surveys. We ask them how much they are spending in the farm, how much they are earning, what's the difference, do they have a really good positive income or not. They don't really tell the truth. Okay. I'm gonna say when you said there is no real data across the country. I don't know about all the country, but in Abu Dhabi we like to have solid data. We are registering data since we started this program, IPL program, since 2012. Okay, and we continue to store data in database since 2016. And like we're following up each year, we want to know the difference. Are we doing very well with our program or not? So we just follow up with it.
There is one question. Thank you. نشكر جائزة خليفة أنها هذه الفرصة لمناقشة هذا الأمر الهام. ويمكن السؤال مبني على أساس أنه هذه الحشرة زي ما قالوا الأخوان اكتشفت في 1985، يعني معناته نحن فوق 40 سنة نحن we are studying this insect, single insect. وأنا أعرف تماماً من الأخ الدكتور حمدو الشفيع، أنا بعتبره one of the top 5 scientists globally في هذه الحشرة. يعني في دراسات كثيرة أنجزت سواء في البوبيوليشن density، سواء في الكنترول، سواء في الكيميكال كنترول، سواء في الكالتشرال practices. And now I am listening to the same studies الكونسورتيوم هذا يقوم بها. فإذا نحن في خلال 40 سنة أو فوق 40 سنة الأوتكم من هذا الكونسورتيوم هو توفير بيانات تبنى عليها استراتيجيز. يعني معناته نقدر نقضي على هذه الحشرة أو ننزلها إلى ليفل ممكن الناس يعيشوا معها، أو أثرها يكون مقبول. يعني يكون بعد 60 سنة إذا كان حشرة واحدة تأخذ هذه المدة. فما هو السنة هذا الكونسورتيوم what is the key outcome؟ what is the key outcome سواء solution سواء ده على أساس أنه الناس ممكن فعلا يقدروا يتحكموا على هذه الآفة. الشيء الآخر يعني التركيز الآن على سوسة النخيل الحمراء، وفي نفس الوقت زي ما ذكر الأخ عندك اللونج هورن ستيم بورر يمكن بنفس الأهمية ويمكن حيكون أخطر. يعني في إقبال تام عن آفات رئيسية في قطاع النخيل. فوات is the outcome؟ what is the key outcome من هذا الكونسورتيوم؟ يعني ما تقولوا لي والله هي توفير بيانات عشان تبنى عليها استراتيجيات. نحن بيناه المفروض يكون عندنا حلول قابلة للتطبيق تساعد المزارع وتساعد المجتمع على التخلص أو تقليل آثار هذه الآفة الخطيرة. شكرا.
شكرا جزيلا أخ دينار على هذه الأسئلة. يمكن أنا ذكرت في حديثي في البرزنتيشن إنه هذا الكونسورتيوم هذا تحالف مكافحة سوزن غير الرابع ننتهج سياسة وأبروتش مختلف تماما من مصر. We have said this from the beginning. يعني من الأول إنه الapproach we are going to use should be different. Otherwise, we are repeating the same mistake, are repeating the same methodology. إذا كان عندك the same methodology, you are repeating it 40 years. في مشكلة في النص. If you have the same result, repeating it with the same methodology for 40 years, لازم تغير المستقبل. So now we are adopting this fragmentation. We are going to look for the population of the red palm beetle. We call it satellite population. في pocket في جيوب معينة. And starting وكل يعني الفئات مؤاتية جدا. For example في الإمارات هنا مؤاتية جدا هذه الفرصة إنه نتجه هذه السياسة، لأنه في بعض الأويسس في بعض الواحات معزولة تماما. يعني مثلا منطقة العمرانية تلقى مجموعة من المزارع معزولة تماما، أقرب نخلة لها على بعد 30 كيلو. And surrounded by a gap, شجر الغاب أو surrounding by the dune of sand. This will consider it as isolated population. We are going to apply the available technology. عندنا التكنولوجيا موجودة، يمكن يكون مشكلة ما من المشكلة من الكوردينيشن participation for parties. فهنشتغل عليها على أساس إنه تسبريز البوبوليشن لحد ما توصل مستوى معين، وهدفنا eradication أو eradicate this area. لكن نحتاج قوانين صارمة جدا. ذكر الأخ الانترنال كرانتين، يعني نحن نعمل eradicate الاريا ما عايزين نخلي يخش إلا يكون خالي من السوسة وننتقل إلى مناطق أخرى، أو بالأحرى نحن يعني كونسورتيوم ما حنعمل مسألة، نحن we are going to teach the NARS هي الفرق القومية how to do this، إذا كان في إيجيبت أو إذا كان في الإمارات أو غيرها من البلدان اللي حتستفيد من الكونسورتيوم. فنعلم كيف يقوموا بهذه المسألة ويعملوا على لارج سكيل، إنه اللارج سكيل is not our job في هذا البروجكت. وأنا أذكر مثلا إكزامبل في دلما أيلاند هنا في الإمارات، فممكن الناس يمشوا إذا فيها ريد بالم بيجل الهدف يكون eradication not containment not reduction of population، يكون eradication لأن دي جزيرة محاطة ببودي اوف ووتر ما في سوسة بتمشي ما لم يساعد الإنسان يدخلها، وبالتالي جرانتي ميجرز انترنت فيري سترونج وتعمل ابلكيشن للفيري اجريسيف تكنولوجي ده او السبريسيف تكنولوجي هيحصل ذلك. فده الهدف من هذه المساله، وهذا البروجكت من الاشياء اللي ممكن نعملها ان شاء الله في هذا البروجكت بدون اضافه جديده. الحاجه الثانيه we are also taking other pressing consideration. انا يمكن اتكلمت عن المالتي دايمنشنال مالتي بيست مانجمنت اللي هي 3MP دي we are considering the long haul because the long haul is also very difficult. يعني the same technology يعني نفس التكنولوجيا إذا استخدمنا MMT benzoate for injection to control the red palm beetle it will control also the long haul، لأنه long haul larvae برضه موجودة في النحلة and this transportation also will take it into consideration. Also بتاخد حشرة معاها ثانية اللي هي الأوريكتس برضه بكنترول، وده ممكن يتأخذ في باكج معينة holistic approach، وبالتالي نقدر نسيطر عليه إن شاء الله. شكرا.
I think we need to close the session.
Just final word. I would like to dinner. أنا أحب أطمنك البرنامج ده إحنا we're not just talking about data. إحنا if you look at the presentation of all these work streams, we are data first we are generating data, but also we are concerned with developing technologies. We talked about work stream 1 that working on bioagents that they can help in the fight against the pests. We're talking about developing detection and monitoring tools. That's work stream 3. We are working on products that farmers' technologies can put for wound sealing and also for irrigation of palm trees. But most importantly, this project work stream 5, and all of us are working on these packages, what we call them, the bundles. Because the idea of controlling is how to put these bundles together for integrated management. And this is also something new. So this is about technologies, this project, not just that. And hopefully in 3 years' time, we will be able to have products we put in the hands of the farmers and policymakers to help them in the fight against this pest, not only data generation.
Thank you. And this is one more intervention before we close.
Thank you. Just a very quick question. Now that the project is underway and all of the agreements are in place, can we have a very clear, quick summary of what the deliverables and the timescales are, please? Just so that I think it would be helpful
I think I can answer this question. The timeline that we have so far is like we mentioned in our presentation, we have just started. Our first year is about to complete, so research is ongoing on all of the 5 work streams that we have discussed. So right now, each research is coming into a conclusion to go ahead and offer one of the solutions that work stream 5 of us is going to go ahead and test it in all of these sites that we have selected. So our goal and aim is that by the second year, that is starting in 2 months, we will go ahead and have at least few of the final solutions from each of those work streams to go ahead and scale it up in these sites. And then before the end of the project, which is in 3 years, July 2028, our aim is that we are able to have like a final package of the bundles that will be selected for all different kind of science that we are talking about, like each of the environmental area, and then we'll go ahead and apply it to some of these low and medium income countries.
Thank you, Mujib. And as we now bring this conservation session of the Consortium we will control to a close, I would like to thank our colleagues for the great interventions they have been making. Thank the audience for asking very, very timely questions and for the remarks we made about the past investments and the future of this consortia and how can we continue supporting the farmers, but also getting engaged with the industry to see how they can actually add value to, as we move forward with our intervention, how do we engage other actors into the project. And I would like to take a moment to reflect upon the key lessons that emerge from our discussion and what they mean in our road ahead. Through today's discussion, one thing that has clearly emerged is that no single group, institution, country can address the daunting challenge presented by the Weevil alone. We heard the strong alignment from our key speakers. We also had very distinguished important interventions where 3 things have been highlighted very strongly. Early detection, early warning, and early action are key when it comes to fight this pest. We also seem to be a very clear consensus that we must allow for best global practices in agriculture to guide us in reminding the foundations of any substantial strategy. Finally, we found the alignment on both the potential and the limitations of using advanced technologies and strengthening more coordinated, evidence-based response in the fighting against the red palm weevil. But perhaps most importantly, we learned that collective action, this is something that was highlighted by everyone, collective action. So everyone is a stakeholder of the solution. From the government, from the science, from the farmers, and everybody else that is involved in this process. So isolated efforts we have limited ability to achieve the impact that we want to achieve. So today's exchange highlighted concrete opportunities for collaboration, joint validation of detection and monitoring tools, regional approaches to surveillance and data sharing. Data sharing was very important. Coordinating capacity development and training, pathway for responsible scaling through public and private engagement is important. And these are exactly the kind of connections, coordination, and shared actions that this consortium was designed to be enabled. So I think we are, from that perspective, I think we have achieved our first year of success. And before I give the word to the DG, I want to create the confidence that we can actually work together and looking ahead, particularly towards the transition into the next phases. We have to enable and validate solutions, we have to strengthen policy and regulatory updates, and ensuring the long-term financial sustainability and ownership. And so with that, I would like to pass it to the DG to close the session.
Thank you very much, Augusto. Just a word of thanks to all of you and to continue doing the good work. I just want to come back on one very specific point. His Excellency Dr. El-Doueiri is a former Minister of Agriculture in Jordan, and he made the point about numbers. If this project succeeds, whatever solutions we produce, the ministers who are eventually going to make the decisions need the numbers. We can still highlight the social importance of the small trees, smallholders, but at the end, everything needs to be converted into numbers. challenge, and I think Muhammad Ali Bob mentioned there's a lot of information available, but it's not reliable, it's not verified. And I think this project will have a very important role in building more reliable databases, data sets about the infestation, economic costs, and then eventually at the end will provide information in a way that allows the policymakers in the UAE and across the world to be able to make policy decisions to take off and to implement some of these innovations and solutions across the whole country based on the economic value that this brings. I think we need to understand on the recipient side governments, that's how they operate. So, and I'm happy that this point, Your Excellency, has been raised now, because it needs to be part of the original design. It should not come as an afterthought. I know you are already doing that, but I think bringing a bit more structure, bearing in mind what is the end result that we want to do. And also to mention that Dr. El-Duweri is one of the major evaluators, scientific evaluators of the CGIAR Center more broadly, and ICARDA in particular. So if he raises the point, make sure that he's So thank you so much, Your Excellency, for raising this, and thanks to everyone who have been with us throughout the day. It's really important to recognize that. Thank you, Fatma. Thank you, everyone, and Afshan, colleagues from Oman, Bahrain, and many others who have been very patiently with us throughout this session. So I just wanted to add my word of thanks to all of you. Thank you.
Thank you. So now we are ready to close.
Yeah. I think we can, thank you so much for all the panelists. If you want to stay here, you can stay here, but if you want to go back to your desk, you can go. And should we do the, so just one word that I know that some of you all still have questions. So I have my card here, so we want this conversation to continue. We don't want to just stop here. We are here to listen to you, to your questions, and get back to you all. So please make sure that if you have your question remaining, get my card, send us your questions, and we will be more than happy to engage and answer questions. Right now, if you all can come please here for